Okay, you guys, today's 12.5, probability and the multiplication rule. Okay, so what we have is a compound event. In the past, you guys were just taking, what's the probability of rolling a die of, and getting a 2. So now we're going to do a compound event. It is made up of one or more separate events. To find the probability of a compound event, we have to know if it's independent or dependent. So it's kind of just the way it sounds. Independent is if the occurrence of one event does not, and again, I'm going to explain this, does not affect the probability of the second event. While dependent means depends on one another, if the occurrence of one event does in some way affect or change the probability of the second event. So it's pretty simple. Let me kind of show you guys. So for example, if I'm going to ask you for the following, are they independent or dependent events? So a coin lands up on heads, and then the second coin lands up on tails. Is that independent or dependent? The question is, does this have anything to do with this? And no. So, it is independent. And again, it's independent because the outcome of the first coin is no way going to affect the second toss. So that's independent. In a bag of Skittles, you guys eat a red one and then a blue one. Well, if you're going to say, what's the probability I choose blah, 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 these are dependent. Why? Because dependent. If let's just say there's 30 Skittles in the bag and I take one Skittle, the red one, well, now how many Skittles? I don't care that I took a red. Well, actually, I do care I took a red because I took a red Skittle first of all, so there's one less red Skittle and there's one less Skittle, so they depend on each other. A red card is selected and put back. Then the ace is selected. So the fact that I put it back means that it is independent. I didn't affect the second choice, right? I didn't affect the second picking. Now, if I said I pick a red card, period, then I pick as ace, well, that affects me picking an ace because there's one less card in the deck. So then the next one, if you wear a red shirt today, and then tomorrow you wear a blue. Let's just say you have 20 shirts in your closet. Now, the key word is here, I picked it. I didn't say I washed it and put it back. I didn't say I replaced it or anything like that. So in this case, they are dependent. And again, it's dependent because you have one less shirt. I never said I replaced the shirt. So that's like something with probability of things being dependent and independent. Now, the next thing I want to mention is what we call, is the independent events. Now that you have an idea of which is which, to find the probability, it does vary. So the probability of an independent event, what you're going to see is if A and B are independent, again, nothing affects one another. Whatever I did in A does not affect B. They're independent. Then the probability that they both occur is the way we write this, is hence the multiplication rule. To find the probability of A and B, we take the probability of A's event and we times it by the probability of B. Again, this is when, so this is your independent. First outcome does not affect. So the first, again, outcome, just repeating it, not affecting the second. Right? It's pretty simple. The probability of A times the probability of B. So watch how easy that is. 2 number cubes. And then one red and one blue are rolled. Okay, what's the probability of the outcome that the red, so the first one, is even? Okay, so if you're 1 to 6 even, would be 3 out of 6 for the probability of, let's say, event A. And what's the outcome that the blue is 5? Well, there's only 1 out of 5. 1 out of 6. Sorry. 1, 5. I keep doing that, I think, because I see the 5. 1, 5, and the total is 6. They have nothing to do with one another, so you just multiply. And we get 3 over 12, which is 1/4. That's it. That's all you guys have to do for that one. It's pretty simple. I did that one. Is that in the textbook? Okay. Now let's do our next one. Suppose you toss a coin 4 times. What's the probability of getting 4 tails? This is independent. I flip the coin once, that's not going to change the outcome of my next flip. So to get a tail, 1/2, 1/2, 1/2, and 1/2. It's still going to always be 50%. So 1 out of 16. Oh. So it's 1 out of 16, which is also 6.25%. This is 25%. Thought I copied the question. I did not. I made it up my own. Okay, pretty simple, right? One does not affect the other. Okay, now let's talk about dependent. Obviously, it depends on one another. A and B, if A and B are dependent, then the probability that they occur is, this is the way that you're going to see it written, and I'll explain exactly what it means. They're going to say the probability of A times the probability of B following A. Sometimes they put a line here, B following A. So what, again, it means is whatever you did in one, you're affecting B. So you have to take that into account. You're affecting B, or you're affecting the second pick or probability. I'm not sure the right wording I really want to use. But it's after, okay? So everything is being affected. All right, let's take a look at our example so you guys get the understanding. So it says your teacher passes around a box. There's 10 red, 8 pink, and 13 green pencils. If you and 2 other people in your group are the first to randomly select the pencil, okay? What's the probability that all 3 choose pink? Okay, well first, how many people are there? How many pencils are there? There's 10 and 8 and 13. So there's 31 pencils. Okay, so my first pick to pick a pink would be 8. Now, you picked that pencil, so here is where you times it by the probability B is following A. Because I picked a pink, you have 1 less pink, and you have 1 less pencil. And then the same thing, 1 less pink, 1 less pencil. The huge difference, again, is 1 is less. These were independent, dependent. You multiply, you're going to get 56 out of 4495. Oopsie. So if I wanted to leave that as a percent, what the heck? Oh, man. 56 divided by 4495 times 100. Okay, so it's about 1.2%. Pretty low. Okay. Next, it says, suppose you draw 3 cards from a standard deck. Again, I know we do a lot with the deck of cards. And you are not replacing it. So it's without replacing. So you're not putting it back. So this is dependent. Without replacing is dependent because you are affecting the second choice. Find the probability the cards are drawn in the order. Okay, so how many 2s are there? 4. How many cards? 52. 5. How many 5s are there? There are 5, but now you have to assume that 1 was taken out. Only 1 was taken out. So that means the next one is 51. Even though it says 4, 1 was here. Okay, not a 5. All right, well, you have to assume a 5 was here. So if a 5 was here, then there are 3 5s left, and there are 50 cards left. So when you guys are doing that, you have to assume that you are choosing it. So 4 out of 52, I thought I wrote that somewhere, times 4 out of 51, times 3 out of 50. It's not a pretty answer. Did I make this problem up? I hope not. Did I mess up? 452. Probability to get a 2, 4 2s, 1 5. Oh my God, this is not right. Sorry, I was gonna say something's not right here. Not a 5. That's a little tricky. So how many cards that are not 5s? 52 minus 4, correct? So 48 cards are not 5s. However, you have to take into account this. You have a 2 here. You don't want that 2 anymore. Or you already have 1 2 here. This is a 5, so this is fine. So there's 48 cards that are not 5s. And this is actually a tricky one. I had to think when I almost messed it up. So again, 48 cards are not 5s, right? So one of them is already here. So 47. Again, 48 are not 5s. And you already have one that's here. So now let's try this again. 4 out of 52 times 4 out of 51 times 47 out of 50. Okay, so we get I can't make, I hit the wrong thing. Oh my God. Math, enter. Doesn't want to make it a fraction. So we get about 0.005. So if I move the decimal over twice, you get about 0.6%. So please make sure you understand that. Look here, I messed this one up at one time, but hopefully you get that. Not a 5. So 48 are not a 5, but you have to consider that this is one of the not 5s are here. So one less card is left for the not a 5. It is tricky. Think about that. Okay? So let's go to this one. A heart. How many hearts are there? There are 13 hearts out of 52. Times not hearts. 52 minus 13. Did I not do the complement? Let me just see something. I talked to you guys about complement. That's fine. Not a heart. So there are 39 cards that are not hearts, and one of them is here. One card is here. So 51. And then hearts, well, we know there are 50 cards. One heart is here, so 12. So put it in our calculators, 13 over 52 times 39 over 51 times 12 over 50. And you get 0.045, so if I move the decimal over twice, you're gonna get about 4.6%. So again, that was your tricky one. Be really careful with that one. I messed that one up almost. Okay, almost done. A few more examples. Okay, so here's your next one. So it says, in a carnival game, 3 cards are marked with stars and 3 cards are circles. All 6 cards are placed face down and a player turns 2 over at a time. If the first card is a star and the second is a circle, you win. Okay. You decide to play if and only if you have a 25% chance of winning, should you play and justify. All right, let's figure out what's the probability that I get the first card is a star. 3, how many cards are there? 6. Times, now the second card. Well, there are 3 circles, but there is 1 less card. So it's 9 over 30, which is about 30%. So he decides if he has at least a 25% chance of winning, he should play. So yes, play, because 30% chance. Okay? Number 3, a draw has 12 white, 7 black, and 6 striped. You randomly choose 1 sock without replacing it. So it's gone. It's affected. Find the probability both are white. Okay, so we have 12 white socks to choose from. Let's figure out how many socks we have. 7 and 6 is 13, 12, 25 times. Now that 1 white sock is gone. Think your socks are in balls of them, so they're together. So now you're picking a second. You have 11 out of 24. Okay, let's take those numbers and multiply them. It's about 22% chance. Find the probability that you choose a black and then a striped. So you have 7 black and there's 25. One of them is gone and a striped is 6. So we have, backwards, 7 times, so we have 7 over 25 times 6 over 24. Ooh, you have about a 7% chance. Okay, last problem. So it says you randomly select 2 cards from a standard deck. What's the probability the first card is not a heart, and the second is a heart? If, okay, so part A says you replace. Since you are replacing, they're independent. Okay, so you have 52. What's the probability that the first one is not a heart? So again, 52 minus their 13 hearts, 39. Now, you're replacing. So A is replacing times. Okay, you still have 52 cards, and the second is a heart, would be a 13. Let's multiply. You're going to get about 18.75%. Or you guys, you can obviously put it as a fraction. Okay, and last question, part B, you do not replace. So without replacing. So I just want to show you the difference. Without replacing is dependent. One less card, dependent. One card is gone. So not a heart is, again, 39 out of 52 times 13 out of 51. You're going to get about 19.12%. There's no rhyme or reason why I'm actually rounding for some, not for some. Oh my God, why do I keep doing that? Math, enter. Great. So that's that one. It's pretty easy. I think you guys learned this anyway. Hopefully you guys find the lesson and the homework easy and probability is going well. Bye.